Hi students, in this video we'll discuss about implementation of binary search. The question is, you are supposed to introduce 1D array manipulation and implement binary search. First I'll explain the logic of binary search. Here you are supposed to implement binary search in 1D array, in one-dimensional array, that is nothing but your ordinary array. That is according to the question. And one more thing, when you are doing binary search, you are supposed to arrange the elements in ascending order. Your elements should be in ascending order. Your input should be in ascending order. Right? No change in that. Your input definitely it should be in ascending order. And here you know array index, it starts from 0. Your first index will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and the last index will be 9. And the logic behind this binary search is like the first index will be pointed by a variable. I'll take any variable. Here I have taken as first. And the last index, it is pointed by the variable last. And I have to calculate this. I have to calculate this middle element. How can I calculate the middle element? If I know the first and the last variable, calculating the middle will be very easy. Right? So first plus last divided by 2 will be my middle element. So here, since the index it starts from 0, the first index is 0, the last it will be 9. 0 plus 9 divided by 2 will give you fourth. So what is the fourth element? 0. Index it starts from 0, right? So 4, 0, 1, 2, 3, 4, right? This becomes my middle. Now binary search, I am supposed to search an element in an array. You can take any element in this 10 in this array and you want to search it. Now you can read the search element from the user and you check whether this search element, if it is less than the middle or greater than the middle. Suppose if your search element is 8, it is greater than the middle. So what you have to do, the first index, I told the first index, it will be pointed by the variable first. Right? You are supposed to move this first variable to middle plus 1. Why I am using middle plus 1? What I have calculated, if the search element, if it is greater than middle, right, it is enough to search which boundary? This colored boundary. Suppose if your search element is 8, this 8 is definitely greater than the middle element. Middle is this position, right? It is greater than the middle element. So it is enough to search only this colored portion. Right, this portion. So my first boundary, that is my left boundary, will become middle plus 1. Right, now again you are supposed to calculate the middle. Right, when you calculate the middle, you will be here. Right, then you check whether item what you want to search is equal to the middle element. If not, you have to check whether the middle element is less than the search element or greater than the search element. Less than the search element means you have to move the right boundary. Greater than the search element means you have to move the left boundary. Likewise, you have to do the process until you find the search element. I'll tell you, calculate the middle and then check whether middle element is equal to the search element. If not, you check whether middle element is less than the search. Middle element is less than the search. Middle element is less than the search means your boundary should be this one. You are supposed to search in the right side. So move the left boundary equal to middle plus 1. If not, you have to move the right boundary to middle minus 1. Right, this is what we are doing in binary search. We can come to the program. We have done the declaration. We have taken the total elements. Using the for loop, you read the input one by one, that too in ascending order. And you read the input element, search element from the user. As I said, for left boundary, you are using the first variable, and the right boundary, you are using the last variable. And calculate the middle. Middle is equal to first plus last divided by 2. And here then you come to this while loop and check whether this middle is less than search, right? If middle is less if middle is less than search, what is the meaning? Middle element is less than the search element, right? As I have shown in the diagram, you are supposed to search in the rightmost boundary, so you move the left boundary, that is first variable, to middle plus 1, right? And then yeah, you are supposed to check if middle element is equal to search. If it is equal to search, you can display the element with a location. If not, you are supposed to search in the leftmost boundary. What does this else indicate? Here it is middle is less than search. If middle is greater than search, this will be your condition. Last is equal to middle minus 1. And you calculate the middle and you check at one point of time your middle element will be your search element. Till then you are supposed to move either left boundary or right boundary and you are supposed to search it. Right, so this is all about the program. We can see the execution. Yes, students, we can see the execution of binary search. As I execute it, it is asking the total number of elements. I am entering as 6. And as I said, you are supposed to enter the element in increasing order. And enter an element to find. I am giving us 1. 1 is not found in the list, right? 1 is not found in the array. I'll show you one more example. 1, 2, 3. And if I want to search 2, it will give the location as 2. Right, so 2 conditions. Right, it is an 1D array and the input element should be in increasing order.